In this video, we are going to look at Alwayson. Alwayson is a high availability and disaster recovery solution. If you look into my previous videos about Alwayson in SQL 2008, there are plenty of videos I recorded. You can go through them and then find out more details about the Alwayson, what is Alwayson, and things like that. But I'm just going to give you a brief overview of what is Alwayson before I dive into setting up Alwayson in Linux servers. Let's say you have database server, and this is your primary OLTP database server, and this is your application server, and you have a couple of databases in this database server, and your application server connects to the database server to perform the inserts, updates, deletes, and select operations. And in the Alwayson, you create additional servers. Why? Because you wanted to have a disaster recovery solution. Okay, so what you do, this is your secondary server. You don't call in the Alwayson configuration, you don't call the server. You call that server as a replica. This is your primary replica. This is your secondary replica. So what you do, you take full backup and then restore the database here, and then you take full backup and then restore the database here. For every database that you want a disaster recovery solution, you take copy of it and then restore it here, and then set up the Alwayson between these two servers. Similarly, you can have additional servers. You can have additional secondary replica. This is another secondary. This is a secondary, and this is primary. And then you take full backup and restore it here, and then you take full backup and then restore it here. So if this server goes down, then you can make this server as primary and you can continue your processing. And not only that, when this server goes down, this primary server, you can set up in the Alwayson configuration to automatically fail over the database services from this server to this server. So you can configure that way. In most of the companies, you have a database server and you have primary, you have secondary. This is your primary OLTP database server, and this is your reporting or DR server. So you use this server for reporting or disaster recovery to offload some queries, to run some reports on this server probably. And then this is your primary. So your application is going to perform the inserts, updates, or delete whatever DML operations against this database server, and you don't want to commit on this server. Okay, it will be a performance issue. So instead of taking 1 second, it's going to take 2 seconds or more than 2 seconds for the inserts, because you have to, if you set up in synchronous. So in general, you set up asynchronous mode. You will set up asynchronous mode, and then when you insert a record, the record will be inserted here, and then immediately the application server is going to get a response back from server saying that the record has been inserted. Okay, and then Alwayson software, it's going to copy that record asynchronously to the secondary database server, and you can make the secondary database server as a read-only, and then you can point all your reporting applications or any ad hoc requests or DBA reports, whatever it is, whoever is connecting, whoever want to run some reports or browse some data, they can all go to the secondary server or DR server. And high availability, automatic failover will not be possible when the primary replica goes down. You have to forcibly make this as a primary and make this as a secondary. Okay, if the server fails, it's gone. Let's say it's gone forever. Then you make this as a primary, this server, and then you break the Alwayson, rebuild the server, copy all the database again from here to here, and set up the Alwayson. Okay, that's how you do it. But if there is some glitch or network issue or some corruption or some hardware failure on this server and it goes down, you make this server as a primary replica, and then the Alwayson will be in suspended mode because this server is not available. So once you fix the problem and you bring this server up, then what you do, you resume the always on from this server to this server. When you make this server as a primary, your application server connects to this server. So whichever primary you are going to connect to that. That's why you need availability group, and you create the availability group, the listener. So your application connects to that listener that will route the request to appropriate primary replica. You don't need to say, oh, you are primary. Okay, you need to change the application connection string to connect to the primary replica. So you don't need to make the application connection string changes if you have configured the listeners, but you can run without listeners. In 2017, there are two cluster types. Either you can use the cluster if you want high availability, or you don't want to use the cluster. So it's your responsibility to fail over and then do all the dirty stuff. So it is called as read-only replicas or something. If you go to Microsoft manual, there are various configurations you can use. Three synchronous replicas, two synchronous replicas, and two synchronous replica with a configuration only replica. For example, there is something called configuration only replica. But I don't see any details about this configuration only replica. What it means is, here you have two replicas. This is primary and this is secondary, and the third one is secondary. Sorry, third one is also secondary. So here the third one, it is just for the failing over. It has the quorum details. For example, let me take it to the appropriate screen. Okay, so this is your second configuration only replica. This is primary, secondary, and this is configuration. So the database, the data will be copied between these two servers. So this is just, it contains the configuration of the always on, nothing much. It is a replica that stores just the configuration information in case one server goes down, and then it always on uses this server. It contains the quorum information, and then it can decide which server to make the primary. So that's why from 2000 onwards you will see this additional option, but I don't see any details of it. It just has some theory, but I don't see this option when I set up the always on. Okay, so enough theory about always on. Let's move on to setting up always on. So what I have here, I have three servers: SQL AG1, SQL AG2, and AG3. I created three Linux servers and I installed SQL Server on three Linux servers. That's it. Okay, it has nothing in it. Now I'm going to set up always on between these three servers. I have created document of what we need for setting up the always on. So I created three servers. SQL AG1 is a server name and the IP address is 120, and other servers 121, 122. I'm going to use the availability group, the listener. This is the listener name, and then the IP address for the listener name. When you create these Linux servers, make sure you select this high availability option. But if you are not installing through GUI method of creating the servers, then you have to add the high availability add-ons while creating the server. Or one, even if you install the server with minimal configuration mode, you can again say, okay, yum install whatever the high availability components you can add later. That's not a big deal. Since I used everything.iso file to install the Linux servers, I selected GUI because I know I'm well familiar with Windows servers. Since I don't know much about Linux, I used GUI version of the Linux, and then I selected this option. So for these three servers, make sure you select this option. So, and then I install the SQL server on three servers. So that's all I did. Now let's set up the always on. So we have to make sure these three servers, since we don't have the DNS, we have to set these values in the host file to resolve the names. So if I say if server 1 connects to server 2, so if that has registered or entry in the host file, so it can quickly resolve rather than going to the DNS. I don't have the name servers on these Linux because I haven't joined these Linux servers to any DNS servers. So let's make sure we have these entries in the um, etc host file. So So these are the three servers. This is SQL AG 1, 2, and 3. All right, we have created those entries. I have disabled the firewall, and then we don't need to set any rules in the firewall because I don't have firewall. But if you have any third-party firewall or firewall is outside the server, and then you have to make these entries in the firewall to access the servers. Let's create these alias in the. So what I'm doing is I'm creating some alias, so I don't need to type SQL CMD server name, user ID, password. So I can quickly enter okay SQL login, and it's going to log in to the server. Okay, so that's what I'm doing now. All right, so now it's time to deploy the pacemaker cluster. So what I'm going to do, I'm going to install the cluster software and then create the cluster. So first I'm going to cluster these three servers, okay, and then I'm going to install the Alwayson components. Okay, so first to create the cluster, cluster software will access the SQL server. So I need to create these logins in the SQL servers. So instead of accessing the, I can say SQL login one. Uh, I have to reload. So instead of executing the statements here, so what I'm going to do, I have the Windows server, and I can connect from Windows server to these Linux servers. So I'm going to execute the command, the statements from the Windows server. So I'm going to use my management studio. So pacemaker is going to use this login to connect to the database server, and then it queries the availability group status and find out who is primary, secondary, and then failover. Basically, it needs access to the SQL server. That's why we are creating a login for the pacemaker, and then giving SA permission, and then we need the pacemaker permissions here. So we need to create a file and put this username and password in that file, so that pacemaker will use that file. The credentials are stored in this file. Okay, so let's execute these commands. Okay, so now we have this file. If you see this file, it has a username and password. That's all we did, nothing much. And then now we are going to install the pacemaker software. Okay, so here we are installing pacemaker and then PCS, the fancy agents and resource agent, whatever the packages that is required for setting up the cluster. Okay, so I copied this line from the Microsoft manual, so you can go there and see that information. So it says the pacemaker is already installed because we have selected this option. So the whatever the high availability the software, it's already installed. We don't need to. But if you are installing from minimal configuration mode, probably you need to install them here. That's why I added this step. So there is no harm executing again, because if the software is installed, it's going to come back and say it's already installed. Now we need to set up the password for the cluster. When you install the pacemaker, it creates a default user. The username is HA cluster. So all you need to do is just set up the password for that username. I'm going to use admin123 wherever the password it asks for. All right, now we need to. There are two components, pacemaker and corosync. So these two component works together for our cluster setup. Pacemaker is a resource manager kind of, and then corosync communication between the servers. Okay, so here we are enabling the PCST daemon, and then start. We don't need to check the status. It will be running. So let's enable the pacemaker software. So when we enable, what happens when the server is rebooted? So it will automatically start that service when server is rebooted. So now let's create the cluster. So to create the cluster, this is the command PCS cluster. First, we need to authenticate all the nodes in the cluster. I'm going to use these three nodes because these three will be the three replicas in my always on setup. Okay, so if typically you will be having two replicas, so in that case you won't be saying SQL AG3. It is just a cluster authentication SQL AG1 and AG2. Okay, since I'm going to set up the three synchronous replicas. Okay, this is the setup we are going to do. The Microsoft manual has all the details about this, but we are going to try other scenarios in this demo. So create the let's set up the cluster, and then now let's run this setup command. First we authorized, and then start the cluster. These commands are pretty much same if you are setting up the cluster in Linux. If you watched my previous videos, clustering in SQL Server on Linux, so I'm going to use the same commands that I followed earlier. Now we need to start the cluster. So we authorized the cluster. What are the nodes that are going to be authorized, and then set up the pacemaker and then corosync configurations. Now we need to start the cluster and then enable the cluster on all the nodes. Now let's type PCS status. You will see these are unclean now. So if you run it again a couple of times, you will see Sometimes you don't see it does the things faster, so you have to wait, so now you can see, okay, it changed. These three nodes in the cluster are online. You can see here, this is the stack, corosing stack, and this is the cluster that we created, just Linux cluster. We just configured three nodes. These three are online, and corosing, pacemaker, and PCSD daemons, they're all running now. Okay, so you got to make sure these things before you proceed. It has to be active and enabled. All right, our next step is to configure the cluster. So we are not going to use the Stonith, and we are going to set some parameters that for this demo. But in the production, you have to configure the Stonith device. The Stonith is it stands for shoot the other node in the head. Okay, it's a fencing for the cluster. So it is very important concept that you have to configure a device to properly set up the quorum in the Linux cluster. So for this demo, since I don't want to install the file share for setting up the quorum for this setup, typically when you set up the always on in Windows, you use the file share to put the quorum there. You have two nodes and one file share, right? So you got three things there, three votes. Okay, so odd number of votes. So you can configure that way. But here, that's why I'm using three nodes here. So my configuration, the quorum will be in the master database. I don't have any file share, anything like that. But you can use Stoneit to configure a device, and then you can put the quorum information there. But for this demo, I don't want to configure too much. So I'm just going to bypass this way. So I'm going to set these cluster properties, and then you can check the status. So everything is good. So our next step is, okay, just reboot the servers. Since we have created and configured the cluster, reboot the servers. I'm going to pause the video here and then resume once these servers are online. Okay, so all three servers are back online. Now we can check the status of the cluster. So everything is great. It says, yeah, Stoneit is good. Otherwise, it will show a warning message here. There is no warning message because we disabled the Stoneit. And then all three nodes are running. So now let's move on to setting up the cluster, sorry, the always on. So we have to enable the HADR in the SQL Server. In Windows servers, you will use the configuration manage to enable the always on feature. But here in Linux, you got to set this configuration in the configuration file. So let's we have to install the high availability packages. Since we don't have firewall, I'm not going to do anything here. Our next step is to create the master key. So what happens here is you have to create the master key to access the endpoint. So you create a login and then create a certificate and then use that certificate using that master key to the endpoint. So what you do, you create the master key and then create the certificate, and then you use that certificate to create the endpoint, and then you back up that certificate, you copy that certificate to replica, secondary replicas. You do the same thing because every replica can become primary. What you're going to do is you're going to create the certificate, to access endpoint and then copy the certificate to other servers. Similarly, you do that on this server and this server. Okay, that way primary can send the data, the log records to the secondary servers. And once this becomes primary, and it can send the records to the secondary server, which is this server. So that's what we need to do. So first we need to create the master key. So I'm going to use Management Studio, copy these lines. Okay, so this is what I'm going to do. Create master key and then create the certificate and then use that certificate to uh, for that endpoint and then back up that certificate and then copy the certificate to other two secondary replicas. Okay, now I'll have the certificate in this location. I need to do the same thing for other servers because I might fail over the availability, make the AG2 as a primary or AG3 as a primary. So I'm going to copy. So run this. So now I have to copy those files. So I use the SCP, secure copy program. Now I'll have the files. Here. Okay, I copied here. Same thing. I have the files here. So now I got to do the same thing here. Since this file, I created the file here. I backed up the file, the certificate which I created on CAG2. I need to copy this file to the other servers. So I need to execute. Typically in Windows environment, when you are setting up the SQL Server always on in Windows, you won't be executing any of these commands. You won't be creating the certificates and then copying the certificates, whatever it is. So when you set up the always on through GUI, it just creates all these things for you. So but in the Linux, you have to do a lot of things. Whatever the Windows version is doing behind the scenes, you got to do a lot of things in the Linux manually. So essentially what happens is, you have to access the endpoint. The always on is going to use the endpoint in Linux to copy the data. So you have to create the certificates and assign the certificates to that endpoint and then create the logins to those certificates and then use the endpoints to send the data. Okay, so you got to do a little bit of work there. So that's what I'm doing now, setting up the prerequisites for always on, how to copy the data before we actually set up the always on. Let's see if we have copied the certificates. All right, I got all the certificates here, the three servers. So this is the AG3, and then remaining certificates are here. Similarly, I have the three certificates here. I have the three certificates here. Okay, so I'm good. So now I need to make sure the certificates are owned by MS SQL account, not by the root accounts. So that's what I'm doing now. Okay, changing the ownership of the certificates I created. Okay, so now I have to create a login because these servers, these three servers, they are going to connect to the other servers and then use the certificates, right? So the other servers when AG2 and AG3, when it connects to AG1, it needs to log into the SQL instance on AG1. So that's what we are doing now. Okay, we need to create the logins on all the server for accessing the availability configuration. So create the same login on all three servers. Since we copied, the other two certificates, we have to use that certificate for accessing the login. So that's what we are doing now. So we have to grant some permissions to the endpoint for that login. Since we already created this login, we just need to grant access to those certificates for that login. So if you are setting up, say, Alwayson in Windows, probably you won't be doing a lot of this work. You just going to use the GUI to identify the replicas and then the databases, and then set up 99% of the things that you don't even sometimes know what is happening behind the scenes. The certificates, the connection, the endpoints, permissions, a lot of things. But here you got to create those things here. Now we have created the prerequisites for creating certificates and endpoints, etc., etc. Now we are ready to set up the always on. So to create always on, I think we have to refresh. Okay, so let's create the always on. Availability group name is SQL AG. So this is the cluster type, something new in I think Windows, 2016. I don't know. But this none means you are not going to use the cluster, Linux cluster. The external means you are going to use the external cluster, which is pacemaker in the Linux. So if it is a Windows version, you will see a different option there to use the Windows cluster. In the Linux, you have to use the external. Okay, because since we need the high availability when one server goes down or something happens to the database instance, you wanted the always on to failover. To have the failover capability, you need to use the external option. Because you're not going to set up read-only replicas. Sometimes you can set up read-only replicas. For that you don't need the cluster. But for this demo, I'm going to use external, so that I can use the pacemaker, because we already installed and configured the pacemaker. We have created the cluster, right? So we are going to use that cluster. The cluster is going to access these databases and then failover. So when you move the database, see, when you manually failover from one server to other server, when you make SG2 as a primary, then you have in the Windows you have an option, just right click on it and failover. right? So it is going to use the Windows cluster to do the failover and then access to the database and then execute some commands, make the secondary as primary and the original primary as secondary and a lot of things. Here you are going to do all those things manually using the Linux commands, Linux the pacemaker commands. All right, so we are going to use the external here. Click next. There are no databases, so let's create a database. I'm going to create the test database. Full recovery, it has to be in full recovery. And then you need to create a backup, full backup, and then take a log backup. Now if you go back to the screen and refresh, you will see that okay, testdb, it meets the prerequisites. Select the database, and in future if you are going to add additional databases to the existing availability group, you can add it. Okay, you can remove the database, you can add the database in the availability group. So now click next. So here availability replicas. So this is the whichever the server you are trying to create the Alwayson, the availability group, that replica will be selected and that role is primary. When this becomes secondary, you want the databases to be read only or you don't want to read the databases. So you want synchronous mode or asynchronous mode. I told you earlier, synchronous mode, that means you wanted the data to be the same, hard standby. I'm going to add SQL AG2, that is my another replica, and this is my third replica. These three servers. So these three servers, you can see here AG1, AG2, and AG3, and then here all those servers. I got to select all those things. And then failover mode external, because we already selected external earlier, so that is going to be carried over here. So you cannot change the failover mode for one server one way, other server another way. So you can say asynchronous mode or synchronous mode here, but for now I'm going to use the synchronous mode. Yes, sorry, let's check it as a, let's make it as a synchronous mode. So when you insert record into AG1, because this is primary, and then record will be inserted here, and then finally acknowledgement will be sent to the user saying that your record is inserted, because you inserted in one server and it inserts into all servers, and finally response will go to the user. So it is going to take some time, instead of taking 10 milliseconds, it's going to take 30 milliseconds or maybe 50 milliseconds, depends on the network connectivity between the servers. If there's poor network connectivity, it has to insert in all the servers successfully. It has to harden that log record in all the servers before it sends a response. Okay, if there is a lag, then there's going to be performance degradation. All right, so these are the replicas in my Alwayson availability group. And then endpoint, you don't change 5022, this port number, you just leave it. Make sure this port number is open. If you disable the firewall, you don't need to do anything here. Backup preferences, if you want to take backup, where you want to take backup, preferably from the secondary replica or primary replica, or where you want to take. Okay, preferred secondary replica for taking backups. Okay, that's a default option in 2017. So you can say primary, it's up to you. Listener, you have to create the listener. I told you earlier, you don't need to connect to a specific server because you don't know which one will be primary, right? This is always going to be primary and it never fail over to other servers. Then you don't need to create listener. You can always say in the application connection string SQL AG1. Okay, you can skip this part. Okay, since I wanted to set up the listener and then create a full-fledged Alwayson. It's not going to harm anything to create the listener. You can have one even if you don't want to use it. So let's create the listener name as SQL AG. Okay, SQL AG is a listener name as well as the availability group name. Don't get confused. I use the same name. You can always say SQL listener or something. Okay, I'm going to use the same thing. So port is 1433 because it is I'm going to use the same database port, default database port for the listener. You can create any port number you want. And for the listener IP address, if you have seen my so this is my IP address. This is the listener IP address. I'm going to use this IP address here. Okay, 123, and then click next. Automatic seeding. I think that is something new in SQL 2016, I guess. Automatic seeding is it's going to use the endpoint to copy the database to the other server. So you need to have same folder locations, file locations, and things like that. Since I'm using the default, I have installed the SQL Server in default location. I haven't changed anything. All three servers have same are installed in the same location. And moreover, this database is small. So I can very well use automatic seeding. This setup is going to use the endpoint to copy the database and then create the database and then set up the database for me. But if the database is huge, you got to take a manual backups on primary database, copy that backup, full backup and log backup to secondary replicas, and then restore it on secondary replicas. And finally, you use the join only. Okay, so because you already did all the work, you copied the database is there ready, restoring mode for you to set up the always on. Okay, in that case, you don't want. In general, if the database is big, you wanted to do the backup and restore on your own. You don't want the setup to do it. Okay, so it might fail, crash. You don't know. For small database, tiny databases, this looks great for me. Super fast. It completed all the prerequisites. Now we are going to create the always on. All right. Now you can see the availability group here, and in the this is primary. Let me refresh one time. Okay, this is primary. This is secondary. This is secondary. So primary, let's see the properties. You can see this property. This is very important. You need to understand this property. It has value 0. That means required synchronized secondaries to commit. So when you insert record into the primary server, how many secondary replicas at least should be synchronized? Okay, before a response goes back to the customer, sorry, the client. When I insert a record into the primary, at least I need to have one secondary to have that record. Okay, then I have to, in this scenario, let's say, I can say like this. I wanted, this is my primary, and I wanted AG2 in the synchronous commit, and at least I need to have one secondary to have the record in synchronous mode. But since in this case it is set as a 0, the reason why it's set as a 0, in the beginning I have selected asynchronous mode, and later on I have checked the synchronous mode option. That is why the always on default setup, it put the value 0 here. That means there is no requirement that secondary replica should have that record. When you insert record into primary, there is no requirement for secondary to have it before a response goes back to the user. When it is 0, you cannot have high failover, automatic failover. If you want to have automatic failover, this has to be a 1, at least 1 or 2 or 3, depends on how many replicas you have. Let's say I put all the values as synchronous and then show the dashboard. Okay, everything is great, everything is synchronized. Let's go back to properties, and this value is 0. So I cannot have automatic failover. In order to have automatic failover, to whichever the server you are going to failover, and that replica, that second replica and the primary replica, both should be in synchronous commit mode, which is already there. All servers are synchronous commit, but this requirement is not met. So I need to have this value 1. I should not use T-SQL way of changing this parameter, this option to 1. But if you have configured the always on in the cluster type as a none, you can use the T-SQL way of doing it. Okay, you cannot change this value using int SQL. Don't try to do that. Okay, even if you do that, it's going to overwrite. The pacemaker is controlling this value in external mode. Cluster type external, pacemaker will change it. If you want to change it, change this value, you have to use pacemaker to change this value. Okay, but this value has to be greater than or equal to 1 in order to have high availability. Remember that that's a prerequisite. And also the synchronous commit, you have to put the secondary replica that you are going to fail over in the synchronous. So now I'm going to update this value to 1. At least one replica, one secondary replica should have the data as same as primary replica. So now to change the value, okay, now we have configured. Now what we have done, we have created the availability group, and now we are saying that this availability group is going to use the external cluster, which is pacemaker. But we haven't created the cluster, right? We have created Linux cluster. What we have is Linux cluster. We added the 3 nodes, but we don't have the availability group role in this cluster. You don't call it as a role in the Linux clusters, you call it as a resource group. But in the Windows clusters, you call availability group as a role. You create the availability group role. In the availability group role, you create the listener name and the IP address. That's it. These 3 servers are not typical the SQL Server clusters. You create a role, availability group role. So when you set up Alwayson in Windows, the Windows setup is going to do that as well. You don't even know that there is sometimes it created the availability group role and then listener name and then IP address. But here you have to create the you have to run execute some commands to create the resources. So here what you are doing is you need to create the resource for the availability group, and you are assigning the IP address, virtual IP. Okay, this is the role that you are creating, and then you are setting up the constraints. Okay, so you need to have you need to add the virtual IP to the listener, and then when you start the role, first you need to start the availability, the listener group, listener role, and then start the IP address. Basically, what you are doing is creating the availability group role and assigning the appropriate order. Okay, that's what we are doing here. So if you have worked on setting up Alwayson in Windows, pretty much you can correlate what you are doing here. Okay, you can understand what is going on here. So let's create, you can run this command in any of these servers because all 3 are part of cluster. You can run this command in any place. So we are not going to use that the configuration file and then push the configuration file into CIB cluster, live CIB cluster. We are just directly running an live CIB cluster now. Let's execute these commands to create the resources in the cluster and set the constraint, and then set the order in the constraint. Okay, now look at the status. Now you can see, okay, now the availability group role in the Linux cluster is created, and it is using the availability group from the SQL Server configuration, and it quickly identified that, okay, this server is primary, this server is secondary, and things like that. You can see here master is AG1 and these 2 are slaves. Okay, the secondary replicas, and the availability group virtual IP address, it started on AG1. So now you can use connect to the AG. You can use this, you can connect from the application server. So let's connect. It is pointing to SQL AG1. All right, so now how to operate and how to manage is Alwayson. So for example, you wanted to manually failover, right? That is one thing you do. You will failover the Alwayson from this server to this server. You wanted to make this as a primary, right? You are going to do some maintenance, or you do something on the server and you wanted to failover to the server. That is manual failover, right? When you are manually failover, make sure these 2 nodes, these 2 replicas it is both are in synchronous mode, not in asynchronous mode. Okay, that is one thing. We already have it when we set up the Alwayson. We already did it. Make sure the replicas that you are going to fail over, they are in synchronous mode. Yeah. The next thing is we need to set the parameter required synchronous commit to 1 at least. So since our cluster type is external, so we are going to use the pacemaker way of modifying that value. So if you set up that value, it won't immediately change. Oops, I think it is failing over. Let's see what happens. Sometimes the behavior is a little odd in the Linux. So when we set that value, it changed from primary to secondary. Now everything is secondary, right? Let's wait for some time. Now you have that value here, required secondary. Now you can see it changed the value to 1 here. Okay, similarly, if you execute this command in the statement in AG2, the value is 1. The value is 1 here. So you now again change the value to, sorry, this AG2 secondary, now it's back to primary. Okay, so you will see this kind of circles sometimes, when you update this parameter, it does changes the replica role here, primary or secondary for a brief period of time until it sets this value. If you see the properties, you will see this value is 1. So it changed this value to 1 on all 3 replicas. Now this setup, now high availability, sorry, the automatic failover is possible because we have the synchronous commit, and then you have this value 1. The cluster type is external, so you have all the things are ready. So now you can do this command. Okay, move the resource, the availability group, resource group. We have created the availability group role in the cluster, Linux cluster, right? So we are going to move that availability group role from AG1 to AG2. That's how we fail over in Linux. But in Windows, what you do in general, you right click on it and say click failover. Okay, then it will ask, okay, which replica you wanted to fail over, right? So it uses the Windows cluster. Windows, it's all integrated. You don't see behind the scenes what is going on. But here we are trying to do this functionality. Okay, failing over from this server to this server. So we got to use this command, fail over this availability group role to this server and make this as a master. So when we execute, it's going to take few seconds. Immediately it's not going to show that information. Still it is primary. Okay, now it is started failing over. Now you can see this is secondary. Now this will become primary. Now you can see this becomes primary, and as usual we didn't do anything to the AG3. It's going to remain as a secondary. So now this becomes primary, the AG2 server. All right, so once you move, you have to clear, you can see the resource status constraint, and you have to clear the constraint because you don't want. So now we can see the constraint. That means here it says we moved, we failed over the availability group to the AG2. So this is not our preferred server. So we got to clear this constraint. So we have to clear that resource. Now if you look at the constraint, again there are no constraints. So the availability group, it's going to be in AG1, AG2. Okay, let's see the cluster status. Now cluster status shows the master is AG2. Yeah, we failed over, right, to AG2. Now it shows master 2 is AG2 and these are the slaves, and my virtual IP is AG2. Now if you refresh, if you execute this command, we are in AG SQL AG here. Okay, so if I execute this command, now it shows SQL AG2. Okay, because the application server is going to use this listener, not the specific server name. All right, so that's how you manually fail over from one server to other server. But if your cluster type is none, you have to change the primary database server as a secondary, and the secondary as a primary, and things like that. So this is how you do it. So automatic failover, these are the requirements we just went through, and we did manually failed over from one server to other server. And then this is the command for the force failover. Okay, so force failover, let's do this. Let's do a force failover. As long as it is one, okay, let's see here. I change it to asynchronous mode for all the servers because synchronous mode is definitely a performance issue. If you are having heavy traffic in the servers, so you cannot use synchronous server. You will see the difference. So if you set asynchronous mode, it's going to stop saying that you need to have at least one secondary to be in the synchronous mode. If I say okay, it's going to give some error, right? So you got to change this value to 0 before I set everything to the asynchronous mode. So let's right click on the properties again. So it changed two of them, but not this one. Okay, because I need at least one. When I click OK, it changed for two, but third one it stopped because of this requirement. Now again, we are going to use this command. Set it as 0. Then it will take some time. So you can come here and then execute. After a few seconds, sometimes it may take 15-30 seconds, depends on how good my servers are. So when it changes the value from 1 to 0 on all the servers, then I can go here and then make all the replicas in the async mode. Okay, it's still 1. Wait for some time until it. Let's see the status of. Okay, it changed the replica role from primary to secondary on SQL AG2, and on here secondary, on here secondary. Okay, so everything is secondary now. So anytime you mess around with that pacemaker, so it's going to bring down the. So I have to wait until it changes this value. Okay, let's try one more time. I don't know why it didn't change. Let's take a look at the resource. Okay, in this resource we have set required equal to commit equal to 0. Okay, we have set this value. It shows it is 0, but it is not updating this value here. So now at this time, what I'm going to do, I'm going to stop the cluster on all the nodes and start it again. Now let's see what happens to this. So it still shows 0, sorry 1. And these servers as all three are secondary. All right. Now what I'm going to do, I'm going to make at least one server forcibly as a primary, because ideally when you set a value to 0, something like this, it should change it. Okay, that's what the manual says. Okay, you cannot change it. But in T-SQL, if you are setting up the value in T-SQL in cluster type none mode, then you have to use this command. Okay, you can set the value in this way. All right, now let's change this value to 0. Let's see what happens. First, let's make it as a primary, because we don't have primary replica, because so all three servers still as secondary. Now I'm going to make at least one server as a primary. For example, this server as a primary, SQL AG1. I'm making force failover, and then what happens? And this becomes primary, secondary, and then AG3 secondary. Now PCS status source clear. Clean up the resource. Now you see the status, and keep executing the status command again. Now it shows age is 1. Okay, so everything is good now. Now let's see the value here. Yeah, now it shows 0. So the cluster, it changes the role, and then it cannot update. I don't know, there is some problem with it could be integration problem. The pacemaker cluster, it is the one that is modifying this value. Okay, we are not supposed to touch this value. You cannot execute this statement according to the manuals. You don't want to set this value. If your cluster type is external pacemaker is using the pacemaker is managing the databases, the always on availability group, you don't set this value. So then it has to properly set it, right? Properly set it as a 0, whatever the value I wanted to set, 0, 1, 2, it has to change it. So it changes the role from primary to secondary, and after that it couldn't update, it just hanging there. So I have to forcibly make some server, one replica as a primary, and then it starts working. There are a lot of gotchas here. Probably you have to be aware of that. So now this is primary. Now I can go to properties. Now you can see that value is 0 here. The value is 0 here on this server. We are in AG1, and then value is 0 on every server, because the cluster changes on all the replicas. Now you go to properties, and now you can make every server as asynchronous mode. There is no requirement for any replica to be in synchronous commit mode. Now performance wise, it's going to be fine, because you don't always on is not going to care about the secondary replicas. The application, whenever it inserts the records into primary, immediately it's going to get the response back saying that your record is inserted, because the secondary always on is going to asynchronously take the data and apply it whenever it's convenience. Okay, it depends on a lot of factors, network availability, or several other things. Now we will lose the high availability feature, that means automatic failover. But what happens if the primary server goes down, right? Let's bring down the primary server. Now the primary server is primary replica is SQL AG1. Now I'm going to stop the SQL server on the SQL AG1 server. Right, stop. Or if we take a look at the status of the cluster is running, but it cannot see AG1 as a primary. It stopped, and moreover it cannot fail over, because this value is 0, right? And other replicas are not in synchronous mode, so it cannot fail over. So always on is not available now the other two servers, AG2 and AG3, will remain as secondaries. You have to manually make the AG2 or AG3. For example, I'm making AG3 as a primary. So if I make AG3 as a primary, you can see AG3, right, should be primary. Changed from secondary to primary, and then now let's bring this server, the SQL AG1. I'm just refreshing this screen. It is showing this replica is disconnected because we just stopped the SQL instance. Now if you refresh, it should come back. SQL AG1 should be available. In the meantime, let's take a look at the cluster status. If it is showing a lot of error messages, you can clean up the resources. So start fresh. Now it shows the master is AG3 and AG2 is the slave, and AG1 should also be slave. Okay, so AG1 also is slave now. Now if I refresh this window, it is still showing as disconnected, but actually it is actually in not synchronizing mode. Okay, so now you have SQL AG. We failed over the services always on to the AG3 as a primary now. Now if you go to the AG2, here if you see this database is suspended. So now you have to resume. So there is a command to resume, or you can just click here, resume the data movement. Okay, this is the statement. So you execute this statement on AG2. Okay, so when you refresh, now it shows, let's execute this command again. Run this command, sorry, the statement in AG1. Yeah, it executed. And then if you refresh, sometimes it does take some time. So you have to be a little patient. Immediately you don't see uh, the icons here. So if you see the screen, now it shows not synchronizing. That means the databases are suspended. Okay, so now it shows this is suspended. Okay, on the primary. So you have to resume the data here. Okay, so now here it shows. Okay, now it's good. Okay, all right. All right. Now all three are synchronizing. So you can see here it is in synchronizing mode because you have set that in asynchronous mode. So this is how you forcibly fail over in case of asynchronous mode setup. All right, let's see what other things we have to cover. I think that's pretty much it. These are the basic stuff. What we have discussed is basic things in always on. There are depends on the setup that you have. You may have to have different queries or configurations or things to know. But these are whatever we learned so far is fair enough for operating the always on.